Alright, we're going to take a look at a different type of integral, and I'm going to put a variable in here, and so it's going to look at something like this. For a, I'm going to have a constant. I'm going to have a 3 here. But I'm going to put a variable up here, and the variable I'm going to put is x. And here I'm integrating not with respect to x, but with respect to t. So I'm going to have t squared dt. I'm going to take a look at what I get here. And I know by the fundamental theorem of calculus, I'm going to get the antiderivative, right? The antiderivative is 1/3 t cubed, and it's going to be evaluated from 3 to x. Now this is my b value. This is my a value. That never changes. And so I'm going to substitute in for t, I'm going to substitute x. I'm going to have 1/3 x cubed minus 1/3 times, I'm going to put that constant in there, 3 cubed. And that gives me 1/3 x cubed minus 1/3 times 27, which is 1/3 x cubed minus 9. And what this is f of x. Okay. And this is called an accumulation function. Okay. By that I mean is if I put in a 4, that'd be like integrating t from 3 to 4. And I would have 1/3 times 4 cubed minus 9. And in this case, 4 cubed is 64. 64 over 3 minus 9 is equal to 64 over 3 minus 27 over 3, which gives me 37 over 3. So I've accumulated this much area. So now if I plug in a 6 here, I'm going to have 1/3 times 6 cubed minus 9, which is 1/3 times 216 minus 9, which is 72 minus 9, which is 63. So I've accumulated more area from the starting point of 3. Now realize some of these graphs are going to go above and below, and I'll give you an example of one right here. I'm going to clear this. And this is the example that's in the notes. I think I go from 0 to x. And I have the cosine of t dt. Again, the first thing I do is I figure out the antiderivative, which is sine of t, because I'm taking the antiderivative with respect to t. And I'm going to evaluate it from x to 0. And I'm going to get, that's going to equal the sine of x. There's my b, minus the sine of 0. That's my a. And so the sine of 0 is 0, and f of x equals the sine of x. So if I put pi over 6 in there, that would be like integrating from 0 to pi over 6, and I'd have the sine of pi over 6, which is equal to 1/2. And if I put pi over 4 in there, that'd be integrating like integrating from 0 to pi over 4, and I'd have the sine of pi over 4. And I've accumulated, and now I have area of square root of 2 over 2. Likewise, if I put pi over 3, I'd have the sine of pi over 3, and I'd get the square root of 3 over 2. And if I put pi over 2 in here. I'd have the sine of pi over 2. I think I didn't say square root through over 2. I think I said pi over 2, but this is square root through over 2. And this is going to be 1. Okay, now, what happens is if you look at cosine, cosine accumulates area all the way to pi over 2. And also, all this is area right in here. And at pi over 2, cosine starts dipping underneath. This is the cosine curve right here. So this area that's starting to accumulate is negative. So my values are going to go down. So if I put 2 pi over 6, excuse me, 2 pi over 3, 2 pi over 3 is somewhere over here, I'm going to be less than 1. And sure enough, I'm going to drop down. That's the same as the sine of 2 pi over 3. And I'm going to get the square root of 3 over 2. And eventually, I'll get an area of 0. Because these two will have, one will have an area of 1 here, and one will have an area of a negative 1 here, and their cumulative area will be 0. So that's what I mean by it being an accumulative function. It accumulates area, both positive and negative, as it goes down. Let me give you one more problem, and I find this really interesting. I'm going to draw you a graph here. And I'm going to draw this. This is negative 1. This is 1. And this right here is supposed to be a semicircle. This is 1. This is 2. This is 3. Okay? So I've got this shape right in here. And I'm going to define f of x. Define it as a function. And that function is going to go from 1 to x of f of t dt. And this is the t curve right here, and this function right here, this whole thing right here, which is a piecewise function, is f of t. Okay, so this means that f of x is the area underneath the curve from 1 to x. Okay, so let's take a look and see if we can figure out what f of 3 would be. F of 3 would be going from 1 to 3 of f of t dt. Well, I don't have an algebraic equation for these, but what I have is an area. So what I have here is I have this quarter of a circle and this right triangle. So I need to figure out what the areas of these. Well, this quarter of a circle, right? It's a quarter of a circle, so it's 1/4, right? Because it's a quarter of a circle, pi times radius squared. Well, this is my radius. My radius is 1 squared. That's what the area of this quarter of a circle is, plus this area of this triangle, which is 1/2 base, and that's this distance from 2 to 3, which is 1, times the height, which is from here up to 1. That's what it's supposed to be. My drawing's pretty poor. And so I get pi over 4 when I do 1/4 pi times 1 squared plus 1/2. So what's this area? It's pi over 4 plus 1/2. The book may say something like this, pi plus 2 over 4, but it's the same value. Okay? So now, let's take a look. Let's say I ask you what f of 0 is. Okay, well, if we follow our, we're going to go from 1 to 0 of f of t dt, and what's concerning about this is all of a sudden a, this is, remember, this is my a, and this is my b, that a is greater than b, and I don't want that. So I have a rule, it's one of the properties. I can switch these. I can put a 0, put the 0 down here and the 1 out here, but I got to multiply by a negative. So it's f of t dt. So what I'm going to do is figure out the area of this and make that value negative. So I'm going to come over here. I'm figuring out the area between 0 and 1. It's also a quarter of a circle, so it's going to be this portion right here. And so this portion right here is going to be pi over 4, but I need to make that negative. So that's my area because 0 is less than 1. I'm going to the left. Alright? So that's how you can use a picture to come up with these values right here.